We are PreDent, Team 6442, a progressive web application that uses machine learning to promote safer driving by predicting car crash hotspots. Car crashes remain the leading cause of death for people under 30, meaning it is incredibly important to address this problem. We noted that most technological solutions combating this problem focus on driver education and safety, and while that is important, we focus our efforts toward a less addressed solution. Thus, we took a unique approach from the Common Hackathon project. Instead of creating an application meant for general use, we developed an application specifically for state and city governments. We plan to implement our software as part of a nationwide plan to promote safer driving and smarter road design, while still catering to general drivers. The core of our project is a machine learning model that inputs static features, such as speed limits, road signs, road curvature, and traffic volume, weather, which is a continuous feature, and many other attributes to ultimately output a map of city roads where hotspots of collisions are likely. We trained a gradient boosting model and a neural network, but we found that the gradient boosting model performed better. Let's go to the government page. Government officials can upload a CSV file of their collected traffic data, which many already have in private storages. This file is uploaded to Google Cloud, and we then input it into our model. Once we finish processing their data, we notify them via email. Our model then outputs 1, coordinates of crash sites, 2, specific issues at each crash site, and 3, a heat map indicating high-risk collision locations. Additionally, we use the model-generated coordinates. We create an interactive map using the Google Maps API. With this information at hand, city designers can informatively improve their roads by determining which roads to fix, which roads need additional signs, where to adjust speed limits, and more. This information is essential for promoting safer roads and infrastructure. Next, let's go to the driver's page. Residents can select a partner city and can view a map with the hotspots of where crashes are likely in their cities and roads. This allows them to make more informed decisions about which areas to avoid and where to be cautious while driving, improving safety. These heat maps can change based on an hourly basis and time of year to account for rush hours and temperature/weather, which both have a significant impact on where crashes could occur. Residents can also help improve the efficiency of our model by inputting data about crashes in their neighborhoods by interactively placing pins on the map, which we aggregate with already provided data. This allows residents to directly contribute to improving driver safety in their neighborhoods, while also allowing our model's accuracy to improve due to the extra data. Lastly, we have a data visualization page, where we show our process of analyzing data and determining which factors are important, accompanied by lots of informative visualizations. After reading documentation, we developed our model and tested it on open source data from the Utah roads, which is for Medium, and produced the heat maps. We collected continuous data by scraping weather and road infrastructure databases. We pinpointed thousands of crash sites as our positive samples and randomly sampled for negatives from locations where crashes never occurred. We used GeoPandas and Fiona to render these images. Instead of just uploading plots and graphs, we rendered our data into real dimensional visualizations and maps as well. This has been PreDent, and we hope to have a significant impact on driving.